Now, Voronoi diagrams. Here in this chapter, you have to know, or if you have forgotten, you have to repeat the topics about the line, about the gradients. So the equation of the line, we know that equals to mx plus c, and if two lines are perpendicular to each other, we have to know that when we multiply them, the result is always -1. And perpendicular bisector, midpoints, all this stuff, you have to know how to find the equation of the line. So let's start. What's the Voronoi diagram? So the Voronoi diagram is in this form. You will see in a coordinate system the points and the regions and the lines which separates the regions. So they have special names. These points, we will call them sites. Later on, we will discuss how it's very actually interesting topic. We will see it in application. First, we need to know what's going on and how to use it. Then these ones, the regions, we will call them cells. And these borders, let's call them border, are called edges. And yes, that's it. We have sides, cells, and edges. And these intersection of the edges, we will call them vertex. So they are vertices. Here in this graph, we have two vertices. So this one is called the vertex. Okay, let's start with the basic ones. Some problem from your book. There is solved problem. You can also check it. And here we have the edges and the sides. The first question is, we have the Voronoi diagram is given. The parcel which cannot be delivered to a location are held at the nearest post office. Okay, these are the post offices. And how many post offices do we have? We have 4 post offices. We need to determine the holding post office for the parcel sent to 0, 0 in the origin. Okay, for this one, actually we have 5. For this one, which one is the closest? If you are here, which one is the closest post office to you is E1. Okay, so whatever in which region you are in, you'll be closest to that post office. So if you are here, you are close to the E. If you're at 4 and 1, let's find 4 and 1, x 4 units and 1 unit, it's here. So you are in this region, in the region of B, so you are closest to the post office of B. And -2 and 0, it will be here. So in which region you are in the region of the A, within the country of A, so you're close to the post office A. If you're in point 3 and -2, where is 3? 3 and -2, yeah, here. So again, it's not on the edge. You'll be closest to the C. If you are on the edge, if you are at some points here, you're both close to the 2 post offices, E and B at the same time. A company leases 2 buildings in the city. One of the buildings is 2.5 kilometers north of the other one. One building is equally close to the post of D and E. So one of the buildings is close to the point post of D and E. You have buildings here, so it must be on the edge. So let's say somewhere here. And the other office is equally close to the post office A and E. So it must be on this edge. If you want, we can use different colors. So it's one first building and the second building. Okay, let it be here. So they are 2.5 kilometers. One building to the north of the other one. So they're on the same axis, just the Y changes. One building is equally close. Okay, determine the location of the building. So actually, I did put them on a purpose like this. So this distance, as you can see, is actually 2.5 units. 1, 2, and 2.5 units. So the 2 buildings are, one of them here, where exact location is -1 and -2. And the second one is here, which is -1 and 1/2, 0.5. So 2 buildings on the edges. So the first part is all about the Voronoi diagram. You just need to realize what the Voronoi diagram is. You have the sides, you have the cells, you have the edges. And whenever I give a point on a coordinate system, you have to tell me to which side it's close to. So it can be close, how you will decide it, in which region, in which cell it is located. If I tell you that the point is here, then definitely it's in cell C, so it's close to the side C.